Hello everyone. Today I'm going to be trying to explain a black hole in the least complicated way I can. Like all the basic parts of it. There's nothing like super fancy about it, but just, the basic parts. Alright, so let's start. So the basic part of a black hole, I'll just explain the definition of one. A black hole is a place in space where gravity is just so strong that nothing can escape. Not light, not anything. So nothing can escape from a black hole. um they form when like super big stars, like really big stars, become like they collapse under its own gravity. Like it runs out of fuel and collapse under its own gravity, and it causes it to become super dense, and it forms into a little, or not little, these things are huge. It forms into a black hole. Let's go to the parts that make a black hole. So the first thing is the singularity point, right at the center. um Actually, I think it's just called a singularity, but we have no clue what goes on in here. But it we know that it's the center of a black hole where the mass is concentrated at the infinitely small point. Um, Now the event horizon, that's right at the edge. Nothing can escape if something goes here, right at the edge of the black hole. If something were to get to this point in the black hole, it's too late because you'd be sucked in. Quick fun fact: if you're being sucked in a black hole and you're being just stretched by the force of gravity, that is called spaghettification, and that is a real word. Anyway, as said earlier, the gravity of a black hole is just so strong it distorts space-time itself, and this is called gravitational lensing. When it just distorts the space-time, just just distorts around it, that's called gravitational lensing. Now, the coolest part, in my opinion, of a black hole is time dilation. So when you're near a black hole, um, your time passes slower compared to like further away, like out here. So if you were to spend 10 years here, I have no clue what the rate of like conversion is, but it'd be a lot longer. So more than 10 years over here. So it's just basically time travel, but it actually is real. So yeah, so the gravity of a black hole is so strong that it affects time. Now, you may or may not be wondering, if black holes are so strong, they absorb all the light, how do we know they're there? Like, how do we know if there's one near us? Like, um, that's due to X-ray emissions from the black hole that we can detect on Earth over here. So there's a theory that a guy named Stephen Hawking proposed that there's radiations that black holes emit over time, which causes them to lose mass, get smaller. And he titled this appropriately Hawking radiation. I would name it after myself too, because that's cool. But I'm just gonna try to help you visualize how powerful a black hole is. So this is space. So imagine the whole universe. This is the whole universe as a piece of fabric. If something heavy goes on it, like a planet per se, it sinks the fabric. If another object comes into play, here's a top-down view of it, it's synced right here. If another object comes into play, let's say a planet around the sun, since this is synced, the object will go around it slowly, like on a real fabric. If you put an object on it and then put another object and spin it that way, it'll orbit around it basically. Fabric isn't really a perfect example because on Earth there's friction and the ball will eventually go down into the center. But there's no friction in space, so it just imagine it keeps going around forever. But it's a pretty good example. So now this is the sun. So let's see here, let's undo that so we have more space. Let's see, this is a black hole. Just that right there, that's the black hole. It just distorts the heck out of the fabric. It has so much gravity that when something comes here, it just sinks right down. Like there's no chance. Like you can orbit a black hole, but if you're in the wrong area, you just sink down. Like it's just infinite mass basically just down here. Now, what happens when you go or when something goes into a black hole? Well, when something goes into the event horizon, which the point of no return, um, it's basically lost to our whole observable universe. We can't see, retrieve anything that's in the black hole. So, in conclusion, a black hole is a region in space that is so strong that literally nothing can escape. Black holes are fascinating, and I actually really learned a lot while researching for this video, and I hope you guys enjoyed it. Comment if you want more videos like this, and I'll see you guys later. Bye.